Thank you.
Good, that was pretty good. And then 17 is maybe a little bit easier, maybe not, I don't know, up to you, figure it out.
Negative once it's past that point.
That's confusing.
Yeah.
So it's just like,
Yeah, that's what I thought. Yeah.
Have I actually done that right?
Except
Yeah.
it's,
Yeah.
it's not including pi over 2 because it's
Because like if k is 0, then it's 0 to pi over 2. If k is 1, it's from pi to 3 pi over 2, etc. If you have the picture, you've already basically done 80% of the work. If the picture's right. You're good.
Yep.
oh, makes sense.
Oh, it's from 5 or 6 to 5 or 6. X is 5 or 6 to 5 pi over 6. Yeah.
so 1 over 2.
Yes.
2 pi k.
You should know what. Oh yeah.
I know, I did. I was like, wait, how much was to write that down over HX?
Okay.
Yeah, I know.
When I say so, you know, you don't do it.
What's on the phone?
The 10.
Wait, 1/2 is like 1 over 2.
I'm not touching the case until you get it right there.
1 over 2.
Yeah.
I don't see the comment like, why is that rebuttal board so unprofessional?
Why did that summary guy pause? Why did that summary guy pause in the middle? 15 seconds.
Wait, does it matter what you
You guys realized that the rebuttal guy didn't have any rebuttals to the other argument. He didn't actually do any rebuttals.
Like this?
5 on the other guy.
Like a
The
bowl?
entire argument. He's like, what? Ace attention? Yeah.
Oh,
Which guy?
What is?
Yeah, I think it wraps
Crap,
around
it
that.
does not work.
Dude, I can.
Yeah, officially.
Wait, it matters what order you put it in.
Yeah, yes.
It's what it goes all the way down, right?
No, it doesn't.
Order, how do you check? It does.
No, because the sign has to be between the three. The sign has to be there. So if the sign gets too high or too low, then it's no longer important. Because it should be plus or minus 1,
That
2.
is from 2
Because you.
Let's get it. Time to study hard.
I just like switched it.
Sign of X.
How's it going?
Yeah.
It's this, right?
Have you never had frosted flakes?
Yes. I've had it like twice not touching that.
That's like a.
There's not a lot of frosted flakes.
My parents never bought me
Alright, so if 2 sine x is greater than or equal to 1, then that means sine x is greater than or equal to half. So when is sine bigger than half? Sine is the y coordinate, so you just make ourselves a happy picture. Zoom, 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 zoom. And the answer is it's everything from pi over 6 to 5 pi over 6 basically. Yeah, say yeah.
Yeah.
Yo!
But shouldn't the circles be filled in?
They should be filled in, says Jennifer, because it's greater than or equal to. So yeah, good, you are correct. So therefore, really, this is everything from 2k pi plus
Plus pi k.
pi over 6 to 2k pi plus 5 pi over 6 with closed brackets, and then we union over all of those. Cool?
Yes.
Yep. How we doing?
Good.
What's up?
Can't think of any clever trick to it.
For 19? Shrish is complaining that it's getting hard now.
Can we use
Do I have to like put my head on my desk?
You just have to be smarter, you just need to make a better picture.
multiple parentheses?
Yeah, I think you probably will have to, yeah.
Oh, like
Mr. Rose, am I able to lift my head ever, or do I have to, like,
Just do your thing, man. It's okay.
Alright.
I don't really care about this video too much because only like 5 people are watching it. So,
Ha.
do you hear that, people watching? I don't really care about you.
Ha.
Just kidding. Love you guys.
Whoops, I moved it.
It should be like this, right?
Okay, I want to wrap this up like pretty
I
soon.
swear that
So,
looks like a null.
put your best 45 seconds of effort into this number 19.
I'm doing it.
Make 2 parentheses.
Yeah.
He said you might
Yeah,
have.
this guy's like under control over here. Are you sharing your wisdom with your table?
How come you have no pictures?
Why did we skip? Why did?
No, I don't know.
You in control of him? Take the village. No, make pictures. You have to make pictures. That's the only evidence that you're doing any thinking.
Oh shoot, I did 18 and 15.
Dog.
Oh, I did 18, that's right.
When is 10x bigger than 1?
Wait, 10?
It's like,
When sine is greater than cosine.
Yeah, when it's greater than pi over 4, greater than or equal to pi over 4, but less than pi over 2. And then here comes the smooth. Well then probably you guys are going to want to draw more things, right? Like, yeah, when does it become suddenly greater than 1 again? This gets tricky, right? It's negative in the quadrant 2. And then, yeah, over here it also becomes like, now it's like a big positive again, right? It tans like y over x. So when the vertical component is much larger than the horizontal component, you have big tans. So I agree, it will be all of this. But due to the glorious period of tan being pi, I can actually kind of just talk about it on the interval from 0 to pi and then just like repeat every k pi.
yeah.
Yeah.
I wonder.
So, I think that this is going to be everything, everyone with me?
Yep.
So this is going to be from k pi plus pi over 4, inclusive, to k pi plus pi over 2, exclusive, and that's just going to repeat every k pi. How are we feeling about this?
Yeah. Does it matter what order we write any of the things in?
Kind of.
lower ones.
Yeah, you have to go in like,
Well, no, I mean like within, like.
like
do you care?
It's awesome. All right. Good. All right. How are you feeling about this? Somewhere towards possibly being able to figure this out? Say yes.
Yeah.
Good. All right. Let's go to the next page, which is hard. We're gonna do 24 together right now. Kind of push that camera.
Oh, I want my
4 sine x cosine x minus 2 sine x plus 2 cosine x minus 1. Alright, this is the kind of crap you came to the Maggie program for. Advanced lessons on serious topics for serious people. Alright. Begin. What should we do first?
Factor.
Yeah, can you be a little bit more specific? Gabe, what kind of factoring? Andrew, yeah, group. That's right. This guy learned from the top, yeah, okay, I'm too tired to make jokes. Yeah, 4 terms, factor right grouping. Do it. Also, Sam, can you raise the backboard?
Right, yeah. I mean, you could have calculated cosine instead if you want. Yes. No, the first one. You can just do it in different order.
Yeah, but then you don't get an actual factor. Second factor is 2 cosine x minus 1.
Factor 2 cosine x.
Oh, I guess.
Yeah. You can do it in different orders. So
Factor out.
Yeah, but that's dumb.
Factor 4 sine x cosine x minus 2 sine x. Like that.
Alright. So that was like, you cool? You just like did it on your head in one step? It's not that hard. Okay. So, upon factoring by grouping, I now realize that things are a little bit more in order, and now it's time to like do some free thinking. So, okay, when is the product of these two things going to be positive?
Time
When they
one.
have the same sign.
Yeah, when they're both positive or both negative, right? So I would like to now know when these are both positive and when these are both negative. So basically what this now boils down to is, dude, I need to know exactly when this factor is positive and negative, and I need to know, Evan, wake up, when this factor is positive and negative, and then I can like be very careful and stuff. Alright, so let's do it. I think the organized way to do this, some kid invented this like 8 years ago, is to, watch this, you're gonna like this. First, set up a side equation of, when is 2 sine x plus 1 positive? Okay, then set up a second side equation, when is 2 cosine x minus 1 positive? And solve each of these separately with their own little picture. Never mind the less than or equal to, like whatever. We can deal with that later. Go, do it. Solve each of these. Solve each of these with a little picture. Wake up, wake up. Blair.
I'll take your word for it.
What it intersect?
Yeah, I'm not worrying about the like greater than or equal to. You need to say greater than or equal to. It doesn't really affect it.
Never do that again.
Less than negative pi over 6 is greater than.
Yeah.
Yeah, don't bother writing anything. Just make the pictures.
Pi over 6 is,
Yeah, don't write it. Come on, man.
Alright. So let's make a picture for when sine x is greater than negative a half. And then let's also make a picture for when cosine x is greater than a half. Everyone, I will wait for you to do that. Yeah? Alright, maybe I'm going too slow. Does everyone agree that this is when sine is greater than negative a half?
Yeah.
Okay. And then when is cosine greater than 1/2? Well, cosine's the x coordinate. So cosine's a half like over here, basically. Wa-cha-cha, wa-cha-cha. All this. Agree? Okay, now here comes the bold and brilliant move. What we want to be able to do is to simply compare these two shaded regions. So we will now create a new circle which superimposes these two.
Big word.
People watching at home, their oohs and ahs are so deep and pervasive that they're inaudible.
Ooh.
Wait, but now they became audible.
You're still
Audible.
doing
$3.
Audible. Get started free 1 month child today.
No.
J, B.
Also, are we in frame? Camera people, are we in frame?
Yeah. Define frame. I mean, you're blocking the picture right now. Alright, you're good. Perfect.
Okay. So, the brilliance of superimposing the two shaded circles is that now we can at a glance look and see what's going on. So for example, from 0 to pi over 3, both of these are shaded. So if both of these are shaded, what's the significance of that?
You know where the stuff is.
Yeah, by my own convention that I just established 2 minutes ago, I shade whenever this is positive and I shade whenever this is positive. So if they're both shaded, then both of these factors are positive and therefore the product is positive. But if one is shaded and one is unshaded, then that means that one of them is positive and the other one is negative and thus the product is negative. Get it?
Yeah.
Yo.
If they're both unshaded, aren't they both?
Also, if they're both unshaded, then that means they're both negative by the convention that I shade positive, and the product of two negatives is also positive. Okay, so I think it's going to be everything from negative pi over 6 to pi over 3. Are you following this?
Yes.
And then from pi over 3 to 7 pi over 6, only one is shaded and one's unshaded. But then it picks up again from 7 pi over 6 to whatever that is, 5 pi over 3. They're both negative. Alright, so I think the like actual final answer is something like 2k pi minus pi over 6 to 2k pi plus pi over 3. And then should be all closed brackets, right?
Yeah.
Watch out. And then also everything from 2k pi plus 7 pi over 6 to 2k pi plus 5 pi over 3. Yeah, but in a more normal situation, they would probably just maybe, a problem might just be like, yo, give me the answer on the interval from 0 to 2 pi. That might be like that will be something that's going to come up in calculus. And then you would just kind of like make yourself a side chart, and you'd be like, all right, here's 0. When does something happen? Something happens at pi over 3. Something happens at 7 pi over 6. Something happens at 5 pi over 3. And something happens at 11 pi over 6. And then you can just go through and make the sign chart for this, right? From 0 to pi over 3, they're both shaded, so the product is positive. From pi over 3 to 7 pi over 6, one is shaded and one isn't, so the product is negative. From 7 pi over 6 to 5 pi over 3, they're both shaded, so they're both negative, so the product is positive. And from 5 pi over 3 to 11 pi over 6, one is shaded and one isn't, so one's positive and one's negative, product is negative. And then again here, they're both positive. Get it? This is, being able to do this is actually more important than being able to do this like kind of weird tedious thing with all the unions. All right, how are you feeling about this topic?
Spicy.
Good, I like that answer. All right, more things. Homework on partial fractions. Let's go. Sam, you're supposed to erase that board 5 minutes ago. Please do so. How was the homework on partial fractions?
The part at the end.
Mile.
First
There was
six
one
questions
that
were
was-
fine, and the last three
Yeah,
questions
right.
were hard.
Okay, good.
There was one that I didn't get.
Edward, can you raise the board, the other board?
Most things are.
Yeah, dude,
Think about it for like a minute or so.
Guys, you just have to look at
Important job. Okay, the homework was, what were the numbers?
I could verify.
5, 9, 11, 13, 17, 24, 25, 29, 31.
Yeah. Okay, good. We're going to put them all up on the board basically right now. This was section like 8 something, 7 something, 8, 7, 4. All right. So here we go. 5, 9, not enough space, maybe 11, 13, 17, and then someone split that backboard up into fourths for me.
I don't know where to move the camera. I'm just gonna keep it.
No, just keep rotating.
Someone split it. Good. All right, here's what we're going to call them out. Andrew Who, number 5. Gabe, number 9. Nate, number 11. Shreya, 13. Margaret, 17. Wait, you're supposed to put the numbers up too. Here, Anthony, 24. Karen, 25. Justin, 29. Robert Peng, 31. Let's do it. Use a good marker. Write legibly. Put the original problem up on the board. Very important.
Alright, William, I'll write the number. Get out. No, Anthony, stop me the eraser.
If you're going to use, I would recommend not using green or red. If you are using green or red, write really big and neatly.
Green, red.
Robert, catch. Robert, look over. I'm gonna throw this at you.
Liam's throw it. You pass it back.
Yeah. All right, fine. Fine. Yeah. Wow. Shoot, what
What are you looking at?
I saw it in his pocket.
I'm getting
said slided before.
Shut up. I don't think you understand. Category guide files How about stuff?
Oh, that was great.
How about this isn't your brother's quinceanera?
We are not getting this.
How would you stop?
Hooray.
Stop. How would you
Just
stop?
pausing during the summary. How about you stop with your
No, it's a review packet for like a month.
How about you stop with your gerrymandering?
Alright, so, as you suspected probably, we are having another test this quarter.
Oh boy.
Woo!
Can I get it?
Oh, man.
Can I get it? More chances for my grade not juicy.
Hey, let's get it. Wait, is this gonna be like a big test or a regular?
Guys, stop playing the points game.
No, I'm wondering if like this is a super big test or.
No, it's a full class.
Oh my.
Yeah, but is it even
But
bigger
at
than
least we don't
that?
have it on Monday though. But I
Yeah,
have tests on Monday.
Wait, no. Did everyone get a review packet for the test?
Yep. Yeah.
Can people who, yeah, okay, well, I'll announce again when everyone's done. So we're having we're having a test next week. It will be a so-called quarter test, but that's kind of like a little bit of a lie. It's going to cover everything we did this whole quarter, but not counting systems of equations and matrices. Because we kind of like did that already. So that means like polynomials, rational functions, and partial fractions. And all these other little things that we've been kind of like doing on the side, such as inverse trig, combinations of trig graphs.
That's all it is.
Yup, pretty much. Inequalities, trig inequalities, and yeah, that's it, I think. Alright, all topics, a detailed topic list will be put up at some point. But it's essentially like, yeah, that's pretty much it. Yeah. It's gonna be this quarter. It's gonna be basically, I can't remember what day it is next week, but it's like next week.
Wait, why are you
I
saying
guess it's Tuesday. It's gonna be Tuesday, Wednesday of next week. Yeah, so like the last day of the quarter, pretty much. And then on the actual like half day, I have no idea what we're gonna do. I might just like not.
Oh yeah, there's a half day.
Yeah.
Ooh.
I'm like a total disaster by the way. Precalc is like not that hard to teach, so I'm sort of like chugging along, but all my other classes are completely falling apart. I'm like so tired, my baby's up all night, I'm getting no sleep. My wife's mad at me for going to work. So like don't expect any kind of quality like anytime soon out of me like this whole year. But Karen, my 80% is still better than most people's 100%, so we persevere. Alright, that was a joke. People watching at home, we are putting the partial fractions homework up on the board. We shall go over it in just a second. People who are putting problems up on the board when you get back to your seat, please confirm that you received a review packet for this test. People watching at home, you better come get a packet from me. And we're gonna go over this whole thing in like 7 minutes. Ready?
That's a very specific time frame.
Number one.
Alright, I hope you can see that.
Just do it. Who did number 5? Or sorry, number 5. Who did number 5? Good. God, you're gonna move the camera as we go.
I will.
Okay, good. Don't zoom in too much. Just like, yeah, it appears to be right. 1 over 2x squared plus x. What do? We factor. We split it up, and then we math it out, and we're done. Good. 9. Also, this is a linear over a quadratic. We have to factor this first, and having factored it, we know that we want to split it up into some number of these plus some number of these, and we do so, and yeah, and then it's just a matter of mathing it out. This person chose to do it the long way. Who are you, number 9?
I will find.
You did it the long way. The fast way is when you just like stick in -1 and then you're just like done in a second. Do you guys remember? Did we do this?
Yeah.
Yeah. Okay, but anyway, you got the right answer. 11. This person also did it the very, very long way. Why you do that? You do that. Okay, good. We have a quadratic over a cubic. We factor the cubic. We factored more. The goal is to split this up into as many pieces as possible, so it's some number of x's plus some number of x minus 2's plus some number of x plus 2's, and then he multiplies through by the LCM, and we get this equation. It is way more efficient at this point to just plug in 2 plug in -2, plug in 0, and then you'll just get A, B, and C, boom, boom, boom. Alternatively, you could expand everything out, collect like terms, set up a system of 3 equations and 3 variables, use matrices even, and then eventually we have an answer which is probably right. Is that right?
Yes.
Good, 13. This one has a little bit of a twist to it now because we have this repeated linear factor. Do you remember this? We talked about this on Thursday. This person who did number 13, you don't think this is right? If it's right, you need to make more noise. Also, these are all odd problems, so you all checked your answers in the back of the book. So
Except for 24.
you should be all knowing if this is wrong.
It is wrong.
Oh wait, yeah. It should be 5.
Okay, go find your mistake.
So I do math.
Your mistake was doing the long way.
Exactly.
All right, good. I don't have any time for this. Good. 17. Is this right? Looks good to me. Maybe. Sure. Good. Okay, to the front. 24. Yeah, just do this. And then also, we're going to erase, as soon as people are seemingly done looking, we're going to erase that board.
Wait, 13's not right. I don't think it's right.
13 is not right?
Or I didn't get it.
It's not right.
13's wrong? Okay, whoever did 13, get up there and find a mistake.
Wait, that's just the denominator. Like, you just factored it wrong.
Who did 13?
It should just be like a plus.
Whoever did 13, just go fix it. Alright, anyway, we're back at 24. 24 is a quadratic over x plus 1 times x squared minus 2x plus 3. This is a irreducible quadratic, and so the best we can hope for is to split this up into some number of x plus 1s plus some number of x squared minus 2x plus 3s. And all we can say for sure is that the degree of the numerator is less than the degree of the denominator, so this person set it up correctly. And then math happened. Is the math all right? Confirmations? Karen says it's right. Trish says it's right. Other people seem to be very quietly chiming in, so I guess that's probably right. All right, 25. Did you read the book and figure out how to do this? Okay, cool. 25. All right, here's where it gets kind of interesting. Maybe, sort of. This is, actually this problem I decided is kind of silly. What did this person do? Did they do it right? Yeah, it looks good. You could also have just watch this. This problem is just it's kind of actually sort of a little bit dumb. Because watch, it's x squared plus x plus 2, right? Over x squared plus 2 squared. But there's just an x squared plus 2 just sitting right there, right? So it's just actually literally x squared plus 2 over x squared plus 2 squared plus x over x squared plus 2 squared. So then just 1. Right. Anyway, so the only problems that were actually challenging at all were the last two, 29 and 31. Let's see what you are made of. Period 3. Let's see if this worked or not. All right, by the way, people are fixing 11 and 13. They're fixed? Good. Good and good. Wait 2 minutes and then erase that board also. Someone? All right, 29. Who did 29?
Oh, I did.
Yeah. Justin says, all right, let's do this. Oh, first of all, you had to do something which I didn't specifically tell you to do in class, but you should have just figured it out. Which is, partial fractions only works if the degree of the numerator is less than the degree of the denominator. So before you can do anything, the very first step is to do polynomial long division, which is a little bit sloppy, but I think the math is right. He does do the polynomial long division. He ends up with 2x plus x plus 5 over x minus 4x plus 2. And at this point, now it's just a chill partial fractions problem, and he just finishes it off. Cool? Say cool.
Cool.
Okay. 31. This one was hard, but fortunately we have very good handwriting. Who did 31? Woo! Woo! All right. Robert says, all right. Man, first I need to expand out x minus 1 cubed. Then I need to do polynomial long division, because after all, the degree of the numerator is greater than the degree of the denominator. So he does all of that, and he receives x plus 3 plus a quadratic over x minus 1 cubed. And then he applies the partial fractions algorithm to that remainder by splitting it up into the number of x minus 1s, the number of x minus 1 squares, and the number of x minus 1 cubes. And that is exactly what happens now. He does the fast way, I think, and he's all done and we're all good. How are you feeling? Say good. Good. Okay. Hey, shut up. Okay, good. Alright, in the last, wait, you're supposed to wait for it.
Me? I just sat down.
Good. In the last 7 minutes of class, I will attempt to have this sort of long-winded philosophical conversation with you about partial fractions, which maybe you're just feeling fine and you don't need to have this conversation, but we're going to have it right now anyway. Sorry. Someone turn the camera this way, and we're going to do this. All right, take the following problem. 4x squared minus 1 over 2x x plus 1 squared. All right. How have you been trained to do this problem? Scott, talk to me.
Alright, so the first one is a over 2x.
Yup.
Second one is b over x plus 1.
Yup.
And then the third one is cx plus d. Oh, wait, just d.
Yeah, over x plus 1 squared. Alright, so, alright, and personally, if I were like a kid in class, I would be kind of like 80% buying this, but like maybe still a little bit like unsure about like, why is that again? Okay. So if that's where you are now, good. What I would like to happen is I would like these 7 people at these 2 tables to just like do this problem right now. Go. Like finish it off as if it's like a normal partial fractions problem. And the rest of the class is going to rebel slightly. And by rebel, I mean we're going to do something a little bit different. We're going to take the same problem. Also, can you like do something with the camera so that both of these problems are in view? If that means moving it far back, so be it. Okay. So what the rest of the class is going to do is just like not ignore this rule that you're supposed to set it up this way. Instead, just be like, you know what? No, this is just a linear times a quadratic. That's all it ever was, and I'm just going to just set it up like a linear plus a quadratic. And in other words, what I would like the other half of the class to do is just write this as a over 2x and just treat this perfect square as if it's just like any other quadratic. And if we're treating it like any other quadratic, what should we say about what's going on up here?
bx plus c.
bx plus c. All right. Is this setup wrong?
No.
Say no. No, it's not wrong. It's just inadvisable, but it's not wrong. All right, so while these 7 are doing this easy part of the problem, the rest of you do this. Go, and then we're gonna join back together in 3 minutes.